Hi, my name is Noah Milder with the University of Wisconsin-Platteville. This past 2 weeks, I was able to work with Dr. Luke Rowland in the automation department within the University of West Scotland on a mobile remote control rover. So the objective of this project was to build and construct a mobile rover that had obstacle detection within it, and also control the rover in some way, shape, or form. Pictured here is the process on how the mobile rover was constructed. Um, First off, we'll just start at the top, go through a little bit. You can see up here as we're just gathering the hardware materials, downloading the Arduino IDE app, which I'm able to use to code. Also then from there we're going to go into constructing the rover, wiring the rover, and the biggest part of it is uploading the code for the rover and then just testing it and understanding the rover functions after testing and uploading the code. So kind of what I'm going to outline in this presentation is how the motor ran, the buzzers and LEDs on the car, um, the ultrasonic sensor which contains optical avoidance, and with that I was able to manually control the rover using an IR controller, as well as controlling the rover using a Bluetooth connection, reading the data via Bluetooth, um, and therefore controlling the rover. There was also a tutorial given to me freely, and this is what I was following for most of the project. It was very nice and it laid out the instructions really well and it gave a lot of insights of what was going on. First off, gathering hardware. A previous student did work on this from home when COVID hit. He was able to take it back to his house and start assembling things. Although when he returned it back to Dr. Luke, he didn't return all the parts. As you can see here, there is a missing wheel that Luke did have to order from the company but he was able to get one with an extra motor in it. Most of the cart was actually already built. This is kind of what it was given to me look like, but it really was not nicely built. There was a lot of wiring issues, missing components. The IR controller was missing, that I will talk about later. And so a lot of the first day I spent was rebuilding the cart and rewiring it. So into the construction and wiring phase, when I was going to be building it, I was following the tutorial provided, which kind of gave step-by-step instructions on how to do it. As you can see here in the picture on the right, it's just kind of it disassembled, with two wheels off, the controllers off, just trying to make sure everything's actually right as according to the instructions. Now, one thing I wanted to point out here, I mentioned about the wiring. You can kind of see that in this area right here, there's 4 pins, but the wires running to it, there's 5. It's supposed to have a 5-pin wire, and so there was a lot of issues with the system in that he wasn't using the wires very smartly. Where he'd have a 5 pin wire going to 4 prongs, which was not an efficient use of the wires and made it a lot more complicated. Where all the parts were given to you, and they were pretty set they were explanatory. Sorry, on how to use it. Yeah, so here's the picture of the final assembly. As you can see, it's pretty functional with the batteries in there, with all of it really secured nice. Wire management's looking a lot better with it actually being used, all the wires. This is what it looks like for the final product. So moving into the uploading code part of it, as I said before, the tutorial was given to me, but with that tutorial also came a list of codes and such. And so right here in this picture you can see all the codes that I was given to work with to understand and upload all the rover's test functions. It kind of goes into all the little details about each function. So it goes over how to turn the motor left, how to turn the motor right here, right here and right here respectively, as well as just combining these two to make this car move and turn. that kind of just goes into that little area, and at the one part of it, it will integrate all the functions and then move on to the next section, which will be servo and ultrasonic range. It kind of goes through that. It starts off small and then it gives a very big code that includes all of the things necessary. So yeah, this is what I'll just be going over for the code part of it. Code was broken up to help better understand the functions, as I was explaining before. The main functions that I was mainly focusing on were the motor runs function, the LEDs and buzzer, ultrasonic sensor, obstacle avoidance, IR controller, Bluetooth connection and data reading, and the Bluetooth controller code part of it. First off, the motor run. Motors both mirror each other's movements. So for this example, the left motor would work together as well as the right motors. So what I'm meaning by that is if the left motor is going forward, the right motor will also go forward to make the cart go forward, obviously. But to turn, the left two motors will both go backwards, where the right motor will go forwards, meaning that car will turn left. In the same way for turning right, the back motor or the right two motors will rotate backwards, and the front two or the left two will rotate forwards. Moving on into the LEDs and buzzer, this was a pretty simple one. The buzzer was really simple. It was just triggered with a simple high or low signal. Digital right is the function that I was using. The LEDs were a little bit more complicated because it did just use RGB lights, setting a set value with the 0 to 255. You can about get any color in the rainbow. That is relatively simple. But it was just basically making all of the LEDs. There was about 5 on a strip, 2 strips in total, with a couple different modes. And so the main chunk of the code was making sure that there was different modes associated with the LED strips. The ultrasonic sensor was a cool one to me because I did have a senior design class that was able to use an ultrasonic sensor, so I am very familiar with how this application worked, and we actually used the specific ultrasonic sensor that is pictured here. You can see the ultrasonic sensor sticking out, this little metallic gray thing. It has an input, or has a receiver, and then it also a trigger. So this trigger will send a sound wave this way, measure the time for that sound wave to then bounce back to the receive pin here. That sound can then be calculated to a distance in the code, and the distance is used to basically gather information which is needed for the obstacle avoidance. That way, once an obstacle is detected, it will bounce that sound wave back off onto the ultrasonic sensor. This sensor is attached to a servo that is able to rotate 45 degrees both ways. So currently it's facing straight. It rotates 45 degrees to the left and right, respectively. Another thing on the ultrasonic sensor is that it uses a PWM pulse to send a sound, so it's just a little square wave and then come back and waiting for the time. And the sense distance is up to 3 meters, which is quite a lot. So how the obstacle detection, obstacle avoidance works is it follows this flowchart pretty strictly. This flowchart is represented in the code with a bunch of if statements. What it does is it takes 3 distance measurements, left, right, and center, which it will then determine how close an object is based off those 3 distances. So if you're following this flowchart here, we're starting getting 3 distances, and then respectively getting each distance. So I believe, yes, so distance 0 here is the left distance, distance 1 here is the center distance, and distance 2, which is over here, is the right distance. So basically, if it follows this flowchart, it will tell the cart which way to move around the object based off these outputs here. And these are just a bunch of if statements in the code, and it's pretty easy to follow. So here's a little video of how the Obstacle avoidance works. It's rotating its servo the entire time. I start walking in front of it, it detects my leg and starts trying to get around me. I try to move around it and it notices it and is attempting currently to just get around me, and it will eventually. It takes a little time. It ain't the greatest, but it will. It does detect the obstacles and does move around you, which is really cool. The next objective was to use an IR controller with an IR infrared sensor to control the cart manually. So pictured here on the right, you can see the controller used. It just looks like a simple TV remote with a power up with those black icons, meaning basically being the forefront behind moving it. So the plus sign here will be used for the forward movement. This right would be used for right, and this left would be using for turning left. This minus sign down here would be used for going backwards. And these numbers 1, 2, 3, 4, 5, 6 were also programmed in there to control the LED light strips in a certain mode and how fast they were changing colors and stuff like that. Very cool stuff to work with. As you can see here, I'm not holding the button on the thing, but when I do, the cart does move forward. I'll show you a video here in the next slide. So yeah, in this video here, you'll see me using the infrared sensor, moving it forward here, and then as you can see here, it's kind of getting blocked by the wires out there in the middle. So I have to move my arm like I used to get the TV signal to work right, and make it move right where I want it to. And so now that this ball here is blocking my way, it's not going to really pick up the signal because the lasers from the infrared don't really go through objects. That's why I had to move my arm in a weird way, kind of like how you're trying to change a channel on TV, kind of like that, using the same technology. But yeah, really the only problem is with this is that it struggles to receive the signal, as you see in this video. It's not the greatest, but it does work, which is pretty cool. Moving on into probably my favorite part of the project was the Bluetooth connection. I really enjoyed learning about this because this was very new to me. So what I was supposed to do is download an app called Freenove on my phone. There was a Bluetooth module that I was able to connect to the rover, and this module was able to send and receive data. So I'll show a picture on the next slide here of what the app looked like. But what the data was being sent from the app is shown here in this table. So if you're getting a move function, this is the command character A that I was getting, and so it just kind of received an X and Y value of where it was kind of going. It kind of has a graph of just a little joystick. So if I'm going up and the right, the controller would interpret that as up and the right in the motor run function. Stop move is basically just when you let go of the joystick there. There's another part where you're able to choose whatever color you want based on a color wheel, so that's the C command there. And then the buzzer is a D. It's just basically high or low, so this could be 2000 or 0. And then the last one, I, is just getting the voltage for me. You're able to see the voltage output for the battery in the car. So this is the app interface. This is what you can do to connect to the car. So this is probably what it looks like when you're opening it up. It says unconnected, and it shows a little picture of the icon there, the 4-wheel drive car that I've been using. This is the joystick I was talking about. So if I'm moving this up here in the upper right division, it will interpret that and move the car like up and to the right. Here's the buzzer. Here's another picture of the color wheel if you select this icon here. This picture here in the middle right is just me connecting to the robot. So I'm going from here, clicking on this unconnected area here. It pulls up this area, and the controller name or Bluetooth module name is BT05. That connects it, and then it turns into this screen giving you the voltage. Where I'm also able to, right now it's in control mode, where I'm able to touch this screen here and just move the controller around manually. I can also put it in obstacle detection mode. Here it's called sonar mode. Tracking mode, that would be where it'd be able to track a line. I'll talk more about that later. But if you flip this switch, it then turns into gravity mode, where it uses your phone to and you can tilt it and it controls the cart like that. It's pretty cool. I enjoyed this part the most because it was the most user friendly. So the improvements that I put onto the codes, it was kind of hard to think of improvements after they already gave it to you. But some of the improvements I did make was the obstacle avoidance in the Bluetooth code was not the same obstacle avoidance I was given in the beginning when I was testing all the functions. And the one I was given before was really good, and it really worked fantastically, and it was a lot more self-explanatory. So I just kind of replaced that code with the new code, and it worked pretty good to obstacle avoid. I also added obstacle avoidance within the IR controller. I kind of went into there. There was a lot of missing keys where if I would say press the 0 button on that IR controller, nothing would happen. But now if you press the 0 button and hold it, it will be in obstacle avoidance mode, which is pretty cool. You get that little diversity in that controller there. I also was able to successfully combine the IR controller and Bluetooth codes. This was a pretty tall task. It was the Bluetooth code was very complicated to understand, but the IR controller was pretty simple and pretty small, so I was able to add it pretty good. I was adding it when the mode was during the touch control mode. We're able to manually control it on the Bluetooth. I just allowed it to be manually controlled by the IR code at the same time. Some improvements I also made I talked about it already, the code or the wiring and construction part of it. Some things were backwards, not there. The wiring was just really bad. So I improved that part of it, and I also added a bunch of comments in the code that I was making. So some problems that I ran into, one of the main issues was the batteries. It was really tough finding what these batteries were. They're 3.7 volt batteries. They're not very common. I think a AA is like 1.5 volts, which is weird that they require these massive batteries. So those were hard to get our hands on. Also, when the batteries did come, they had this problem where they're flat ended. They didn't really have a point where it stuck out. So I was originally using these wires to just shove it in between this node and the battery node. That seemed to work pretty good, but I came up with a more permanent situation by cutting these guys off and then taping it down. It's kind of hard to see in this area, but there's a little wire there that sticks out, and it's electrically taped to hopefully not have to stick just a bare wire in there. Other stuff was the rover drifting. So here's a picture where this wheel, you can maybe see it, it's kind of drifting to the left there. And so what this would do is just make the whole cart drift to the left when it was going forward. Near the end of the project, the batteries, I want to say the batteries were just dying on us, which does not do well for connectivity via Bluetooth. It started kicking me out of the app. It also stopped using some of the LED strips. So this is the picture here. The front one is working, but the back one isn't, even though they're connected wirely, all proper and such. But also the sensor errors. Sometimes the ultrasonic sensor wouldn't pick up an object, and also the line tracking feature for this project was not able to be explored because the reflective object sensors, optical sensors, sorry, what it would do is it just detect a black line, and it would follow that black line no matter what it was doing, but it just it wasn't able to pick up any sort of signal when it saw a line there. Just another issue was that that IR controller was not able to go through objects. It's pretty obvious there, but that is another issue that we ran into. To conclude, this was a great experience that I had in Scotland. I experienced a lot of the country, experienced the culture and stuff like that. So I really enjoyed the experience that I was able to have after this, or have from this. This also was able to make me more broad about the Arduino language and learning more about functions. And with Luke, he was a great mentor with me, and he provided a lot of connections for us. Me and a guy, my buddy Dan, we were working with Luke together, and we've got a lot of good connections, met a lot of good people here, and Scotland's just a great place to be. I'm hoping to get back here soon. It was a great time. That's all for the presentation. Thank you so much, Luke, and for the University of West Scotland for hosting this trip. It was a blast. I hope to eventually visit for other purposes, but thank you so much.